Okay, it's one of those crazy days. We have a series of days. We have a basketball that you go and you fill up, and you fill it all the way full. It has a 25.4 centimeter diameter, and that is at 8 degrees Celsius. And then it wants to know, okay, the next day, what's the size of the basketball going to be if the very next day, all of a sudden that basketball is at 30 degrees Celsius. So you had a warm front come in, and you want to know how this is going to affect your basketball. So let's take a look at this. We're looking at volume and temperature in this case. So V1 over T1 equals V2 over T2. Now, you don't actually have the volume. What you're given is the diameter. But we can assume that a basketball is a sphere. So we can figure out what the volume is of a sphere by saying volume is equal to 4/3 pi r cubed. So we're going to take this value right here. We're going to divide it in 2 because it's the diameter. So if we divide the diameter by 2, 25.4 divided by 2 is 12.7. But remember, that's in centimeters. We need to be working in standard units here, so we're going to go ahead and divide it by 100. And we're going to say that the radius is 0.127 meters. That's going to allow us to go ahead and calculate what the volume is going to be. So, what that's going to look like is 4/3 pi r cubed all of that is going to be on top. That's going to represent volume 1. Now we also have a problem with this 8 degrees Celsius. Remember, when we're talking about temperature in terms of gas laws, you always have to do it on the absolute scale. So 8 Celsius is not going to work for us. Instead, what we're going to have to do is convert it to Kelvin. The Kelvin conversion is actually pretty easy. You just add 273. So when we add 273 to it, this is actually going to be 281 on the bottom. And then equals volume 2 over the temperature 2. The temperature, remember, was 30 degrees. So 30 degrees is going to convert to 303 degrees Kelvin. Now, the problem with this is I'm not actually looking for the volume here. I'm actually looking for the diameter. In order to get the diameter, though, I really need the radius. So I'm going to go ahead and erase this volume 2, and I'm going to write 4/3 pi, and then I'm going to write r cubed. It's going to simplify my calculations just a little bit, because I have 4/3 on both sides. I have pi on both sides, so those actually just kind of go away, since it's on both sides. So really what I have is 0.127 cubed divided by 281 equals 303. So now what I would do is I would go ahead and cross multiply. And when you cross multiply, you'll get 280, I'm going to move over here, get a little more room, 281 r cubed equals 0.127 cubed times 303. So now you go to your calculator. 0.127 cubed times 303 is 0.621. 0.621. And then you still have 281 r cubed over here. So what you need to do is you need to go ahead and say, okay, divide both sides by 281. And when you divide both sides by 281, you get 0.0021. So you get r cubed equals 0.00221. Remember, this is r cubed though. This is not actually what you're trying to find. So you have to take the cube root of both of those sides. And when you take the cubed root, you end up with 0.13. Now remember, that's the radius. Okay, that's the radius of this particular thing. So if we're trying to find the diameter would be twice that, which would be 0.26, which is 26 centimeters. So when you take this thing and you increase the temperature from 8 degrees Celsius, you're actually expanding the diameter of the basketball by 0.6 centimeters, which doesn't seem like a lot, but it is enough that it could possibly pop the basketball depending on what the basketball is made out of.